Ooh, yeah. Ow! Such a tough stick to play with. Ah, so quiet and peaceful. Nothing can ruin this tranquility. My brother! Woo! Except for that. Oregon! Where did you come from? Oh, I just came here to say my brother, because that's my natural pickup line. Yeah, we know that's your natural pickup line, but why do you have to say it all the time? I just told you, bro. Are you deaf? That's my natural pickup line. Well, I literally have no ears, but still I could hear everything. Okay? So shut it. Sorry, she's your brother. Oh, Olivia and Frenchie are here. Hi, Olivia. Hi, Frenchie. Oh, hi. I'm Olivia, and I'm Frenchie. Yeah, never would have guessed. I was talking to the people who are watching this video right now. Oh, yeah. Hey, everyone. I'm Lauren. And I'm Oregon. Ah! And I'm Hans. And today, we're going to be learning about complex figures. Complex what now? Complex figures. What exactly is a complex figure? That's a very good question. A complex figure is a big shape made of smaller shapes, like triangles and rectangles and squares and stuff. This is a complex figure because it is not just a rectangle and it's not just a triangle. It's both a rectangle and a triangle squashed together. That is a complex figure. This whole shape is really a trapezoid, so trapezoids can be complex figures too. Plus, we remember talking about trapezoids in our geometry video, trapezoids. To see this video, look for the Geometry 6th grade video on our channel that says trapezoids after it. Now, what's interesting about complex figures is that there is no exact way to find the area of complex figures because it depends on the shape itself. Let's look at this triangle for a moment. 4 by 4 centimeters. What's the area? Well, I know that the area of a triangle is half BH. Is that right? Yes, it is right. Because it is half of the parallelogram's area, half BH. And the base and the height are both 4 centimeters. So we could take 4 and 4 together and we multiply them to get 16. And we can split 16 in half, which is 8 square centimeters. So the area of the triangle is 8 square centimeters. Did I get that right? Yes, you did. You could also think of it as finding 1/2 of only one of the side lengths and then multiplying that by the other side length that you don't find half of. Huh? Let me make it easier for you, Oregon, so that you'll understand. So, what is half of 4? It's 2, obviously. What is 4 times 2? 8. So you could find 1/2 of only one of the side lengths and multiply that by the normal side length, which you do not find half of. 4 times 2 is 8. That's a clever trick. I know. And it works. Now, the area of a rectangle. Well, the area of a rectangle isn't too tough either. It's just the length times the width. That's right. And there are 6 and 4. What's 6 times 4? 24. That's right. So the area of the rectangle is 24 square centimeters. Great job, because 6 times 4 is 24. But what about the complex figure? Well, the easiest thing about complex figures is that they don't really have specific names. They are just called complex figures because they have smaller shapes inside of them. And also, the formula of how to find the area of a complex figure varies depending on the type of complex figure. Like, for example, a complex figure with a rectangle and a triangle would only require a couple of steps, but some moderate thinking. Step 1, find the area of the triangle. Step 2, find the area of the rectangle. And step 3, add the area of the triangle and the area of the rectangle together to get the area of the complex figure. So basically, you just have to find the area of all the shapes that the complex figure can be broken down to, and then add the areas of all those shapes together to find the area of the whole complex figure. So, based on what we have here, what is 24 plus 8? 32? That's right! So the area of the complex figure is 32 square centimeters, because the area of the triangle is 8 square centimeters, and the area of the rectangle is 24 square centimeters. And 24 plus 8 is 32. Wow, that's interesting. Very, very interesting. And what's also fun about complex figures is that you could split them and split them and split them all over and over and over again to get different shapes every time. Let's go to the next page. Wow, what's this complex figure? From here, it looks like a square. And from here, it also looks like a square, which means in the middle, this must be a square too. Why? Because, hold on a second, if we draw the missing side lengths of the squares, hang on, there we go. If we draw the missing side lengths of the squares, that leaves one square left. Oh, yeah! And since there are right angles over here, then this must be a right angle too. And this must be a right angle. And this must have all right angles too, because it's a square. Wow! But how do we find the area of this complex figure? Well, first, you need to know the area of the squares in general. So, this is measured in yards. Suppose a square has 3 yards in length, but there is 1 yard that is too short. Wait a second. Squares are meant to have equal lengths. Yes, but if we draw this line over here, we could make 2 more yards, which adds up to 3 yards. Oh yeah, there's 3 yards here, but 5 yards is too much. So, we take away 2 of the yards, which is the same length as this, 2 and 2 yards. This leaves 3 yards behind, which makes 9 square yards, because 3 times 3 is 9. But the area of the complex figure is not 9, because we have to find the area of the 2 other squares and add the areas of all the squares together. So, the area of this square is 9 square yards. But what about this square? Let's take a moment to count the yards. Okay, so this side is 2 yards. This side is also 2 yards. This is 1 yard, but if we add another, that's 2. And that's 2 as well, because this is equal to this. So it must be 2 yards. 2 times 2 is 4. The area of this small square over here is 4 square yards, because 2 times 2 is 4 square yards. Ooh, is it finished now? No, we have to find the area of all the shapes and add them all together. Oh, yeah! And the complex figure has 3 squares, so we need to find the area of 3 squares. The area of this square is 9 square yards. The area of this square is 4 square yards. But what about the area of this square? Well, I could see that this is 6 yards long, but if we subtract 2 yards, that leaves 4 yards. There are 2 yards and 2 yards over there too. And these must be 4 yards. Because the sides of the square are supposed to be equal. So if we subtract 2 yards here, 6 minus 2 is 4, so that's 4 yards. Then add 2, we get 4 yards. and these must be 4 yards. So 4 times 4 is 16 square yards, because this square has 4 yards as a side length. So the area of this square is 9 square yards. The area of this square is 4 square yards. And the area of this square is 16 square yards. Now we need to add the areas of all these squares together to find the area. So, 9 plus 4 plus 16 yards. Okay, let's do a little bit of math here. 16 plus 4 is 20, and 20 plus 9 is 29. So what's the area of the complex figure? It's 29 square yards. That's right, because this is the area of one square, this is the area of other square, and this is the area of another square. So adding all the areas of all those squares together makes 29 square yards. That's how we find the area of a complex figure. You find the area of all the shapes that it has inside it and add all the areas of those shapes together. So 9 square yards plus 4 square yards plus 16 square yards equals 29 square yards altogether as the area of this complex figure. But we could also find the perimeter of complex figures, which is tougher, because we need to find the length of these squares and add the side lengths. So how do we find the perimeter of it? Well, first, we have to learn how to find the perimeter of a square. How do you find the perimeter of a square? Well, all of the sides are equal, and the area of a square is bigger, obviously, than 2 of the side lengths of the squares combined. So, 4 side lengths together make the area. So I think we need to multiply one side length by 4, because all of them are equal, to get the perimeter. So, the formula for the perimeter of a square is 4 times one of the side lengths. Let's check over here. 4 times 3 yards is 12 yards. So the perimeter of this square is 12 yards. This is 2 yards. So 4 times 2 is 8. This is 8 square yards. This is 12 square yards, and this is 8 square yards. And this is 4. So 4 times 4 is 16 square yards. This, 4 times 3, is 12 square yards. This, 4 times 2, is 8 square yards. And this, 4 times 4, is 4 square yards. To find the perimeter of a complex figure, we simply do the same thing, except find the perimeter of all the shapes and add all the perimeters of all those shapes together. So the perimeter of this shape is 12 yards, plus the perimeter of this shape, which is 8 yards, plus the perimeter of this shape, which is 16 yards. Now, based on this information, we think that the perimeter is going to be bigger than the area. What do you guys think? Make a prediction. Yeah, I think so. No, I don't think so. What? Okay, let's just see what happens. So let's double check to make sure we are right. The perimeter of a square is 4 times the side length. 4 times 3 yards is 12 yards. That is right, 12 yards. 4 times this length, which is 2 yards, is 8 yards. So we're right for this one. 4 times 4 yards, which is this length, is 16 yards. So we are right. And what is 12 plus 8 plus 16? Well, we could easily figure it out. 12 plus 8 is 20, because 8 plus 2 is 10. Plus carry the 1. 1 plus 1 is 2. So it's 20 for 12 plus 8. And 20 plus 16 is 36, because 20 plus 10 is 30, and 30 plus 6 is 36. So, what's the perimeter of the complex figure? 36 yards? That's right. The perimeter of the complex figure is 36 yards, because we added the perimeters of all three squares together to find the perimeter of the complex figure. That's why complex figures have smaller shapes inside of them. We need to add the perimeter or the area of all of the shapes together, depending on what it asks you. If it asks you for the area, add the areas of all those shapes together. Perimeter, add the perimeters of all those shapes together. And you're right, the perimeter of this complex figure, which is 36 yards, is greater than the area of this complex figure, which is 29 square yards. 36 is greater than 29. So we say that the perimeter is greater. Okay, so, yeah, this is fun. This is very fun. But now, we come down to over here. Oh my goodness, that's a lot of stuff going on. Wait a minute. Is that a kite? Yes, that's a kite. Wait a minute. What is a kite? Good question. A kite is a quadrilateral that has two pairs of adjacent sides, or simply two pairs of sides that meet at a vertex. Ooh, very cool. Yes. However, these two sides are not equal because this triangle is smaller than that one. So this is not equal to this. Although they are adjacent, they are not equal. So the sides are not equal. But the pairs of sides are, because both of these are equal and both of these are equal. So only both pairs of opposite sides are equal, and not all four sides in general. This makes it confusing to understand. But I think we should give this a shot, because we already know how to find the area of triangles, right? Half of the base times the height. Half of 4 times 4 is 8, because 4 times 4 is 16, and half of 16 is 8. So this is 8. But this is also 8, because this is 4 feet and this is 4 feet. So this is also 8. 8 plus 8 is 16. So the area of this whole triangle is 16. And let's find this one over here. So if this is 6 feet, what is this? Well, I know that this line cuts this line into 2 equal parts. So if this is 4 feet, this must be 4 feet. So this is 6 feet and 4 feet. 6 times 4 is 24. Half of 24 is 12, so that's 12. 16 plus 12 is 28. Then, the other one, 6 times 4 is 24. Divided by 2 is 12. So, let's dive deep. What is the combined area of all these triangles together? Well, 4 times 4 is 16. Divided by 2 is 8. Which means that this must also be 8, because this is 4 and this is 4. So 8 plus 8 is 16. 6 times 4 is 24, divided by 2 is 12. 16 plus 12 is 28. And this must also be 12, because this is 6 and this is 4. They are both equal. So, let's add them all up. 8 plus 8 plus 12 plus 12. Well, 8 plus 8 is 16. And 12 plus 12 is 24. 16 plus 24. Does anyone know what 16 plus 24 is? Yeah. It may require some thinking, but yeah, I'll do it. Okay, 24 plus 16. 24 plus 10 is 34. And 34 plus 6 is 40. So the area of the kite is 40 feet. 40 square feet. Wow. Very cool. Yes, that's right. It's 40. Because how do we know that? Well, we added the areas of all these triangles together. 4 times 4 is 16, divided by 2 is 8, which means that this also must be 8. 8 plus 8 is 16. 6 times 4 is 24, divided by 2 is 12. Which means this must also be 12 because these are equal. 12 plus 12 is 24. 8 plus 8 is 16. 16 plus 24. 16 plus 20 is 36. Plus 4 is 40. So yes, the area of the kite, which is really a complex figure because it's split into triangles. The area is 40 feet squared. Wow. Very awesome. I never knew we could find the area of such complicated shapes. Yes, that's right. When you tumble across a difficult problem, you need to really think about it. Are they all labeled? Or does it give you a hint even though it's not labeled? 6 feet is equal to this 6 feet. So this must be 6 feet, and that must be 6 feet. So the height of both these triangles is 6 feet. So math could sometimes give you subtle hints, but not all branches of mathematics give you hints. So you really need to work your way through it in order to solve problems in math. Okay, check understanding. Explain how to find the area of a complex figure. Well, we just talked about it, didn't we? Yes. To find the area of a complex figure, you need to find the areas of all of the shapes that the complex figure has and add the areas of all of those shapes together to find the area of the complex figure itself. Like, arrows are a good example. Arrows are a good example of complex figures because they have a rectangle and a triangle. Let's say this is 8 by 1. Well, 8 times 1 is 8, obviously. That leaves 8. Let's say that this is 2 and the height is 2. 2 times 2 is 4. Divided by 2 is 2. 8 plus 2 is 10. So the area of this complex figure in this scenario is 10. And how do we know that, kids? 8 by 1. 8. 2 by 2, 4. Divided by 2, 2. 8 plus 2, 10. Yes. So, 8, 2, 10. Yeah, it's like an addition problem. Watch this. The rectangle is like the first number in the addition problem. The triangle is like the second number in the addition problem. And both of them together represent the sum. It kind of looks like it. 8, 2, 10. But only because we found the area of those shapes. 8 is the area. 2 is the area. Those areas together make 10. Wow, that's cool. Yes. You could also play around a little to see how many shapes you could split apart. And to test out your skills. Because the more shapes you split a complex figure into, the more thinking you have to do. Because the more shapes that are involved, the more area formulas you have to solve. So this could really challenge you. It's like a detective, a math detective. Ah, math mysteries. Woohoo! All right, that's it from us today. I hope you enjoyed the video about complex figures and why, although they are complex and although they are figures, I take it too literally, they could be quite easy if you get the hang of it. Ah, this nice arrow. Bye! Doo-doo-da-doo-doo-doo. Let me guess. You're about to say, yes, my brother. It was a good time solving math mysteries with your brother. Yeah, and I guessed correctly. Doo-doo-doo-doo-doo-doo-doo.